Dear students, topic of my today's discussion is growth and decay of electric current in LR circuit. LR circuit means circuit containing inductance and resistance in series with each other along with the source of EMF. Now, in order to study the growth and decay of electric current, ਅਸੀਂ ਇੱਕ inductor of self induction L the resistance R. So these are connected with each other through a Morse key, and battery is connected in series with the combination of L and R. ਜਿਉਂ ਹੀ ਅਸੀਂ ਇਸ ਕੀ ਨੂੰ ਮੌਰਸ ਕੀ ਨੂੰ ਪ੍ਰੈਸ ਕਰਾਂਗੇ ਪੁਆਇੰਟ A ਤੇ B, these will be connected with each other. This battery is connected across L and R. क्योंकि बैटरी कनेक्ट होएगी, this will produce the electric current through this circuit. Because of self induction, magnetic flux linked with the coil L as increases, induced EMF is produced across the inductor. ठीक है, सेल्फ इंडक्शन करके क्योंकि करंट राइज कर रहा है, राइज करन ते मैग्नेटिक फ्लक्स चेंज होएगा which is associated with the inductor. Induced EMF produced is minus L into di by dt. This induced EMF opposes the applied EMF. Therefore, rise of the electric current through this circuit will take finite time to become maximum. At any time, suppose I is the amount of electric current flowing through this circuit and is changing at the rate of di by dt. So, induced EMF produced in the inductor is minus L into di by dt, and the potential drop across resistance is equal to IR. Applying Kirchhoff voltage law, we get E minus I L into di by dt is equal to I into R, and E is equal to I into R plus L into di by dt. In this relation, E represents the EMF of source connected across the series combination. Now, solving this equation, we get I is equal to I naught into 1 minus e raised to the power R over L into T. This relation represents the electric current through LR circuit at any instant of time, and I naught in this case represents the maximum electric current through the LR circuit, which is equal to applied EMF over a resistance आ जाएगा. ठीक है, with the passage of time, electric current through this circuit increases exponentially, and in this relation, L over R ratio has got the dimensions of time. This term has got the dimensions of time and is known as time constant of LR circuit. This is termed as a time constant of LR circuit. If L over R ratio is small as compared to 1, means current takes small time to become maximum, and if L over R ratio is large as compared to 1, means growth of the electric current is small. So, L over R ratio determines the rate of growth of current or rate of decay of current in the LR circuit. अगर L over R ratio यानी कि time constant small है, तो then current will rapidly rise through the circuit. If L over R ratio is large, then it will take large time to become maximum. According to this relation, electric current at time t is equal to 0, at time t is equal to 0 is given by I is equal to I naught into 1 minus e raised to the power 0, or is equal to I naught into 1 minus 1 is equal to 0. So, at time t is equal to 0, current through the LR circuit is equal to 0. Initially, inductor offers infinite resistance to the flow of current, because starting the which maximum induced EMF produced on there is maximum rate of change of magnetic flux. With the passage of time, e raised to the power minus r over l into t, this term goes on decreasing. ये term reduce होएगी, exponentially decrease होएगी, and at time t is equal to infinity, at time t is equal to infinity, I becomes equal to I naught into 1 minus e raised to the power minus infinity, or is equal to I naught into 1 minus e raised to the power infinity, or is equal to I naught into 1 minus 1 over infinity, or is equal to I naught. So electric current in the LR circuit becomes I naught, which is equal to E over R after infinite time. So current becomes maximum in the LR circuit after infinite time. ठीक है, and this current may be termed as a final steady current through the LR circuit. ਜਿਹੜਾ ਇਹ current ਹੈ ਇਹ final steady current ਹੋਏਗਾ. ਜਦੋਂ finally current steady ਹੋ ਜਾਏਗਾ, ਇੰਡਕਟਰ ਦਾ ਕੋਈ ਰੋਲ ਨਹੀਂ ਰਹੇਗਾ ਇਸ ਸਰਕਟ ਦੇ ਵਿੱਚ. ਜਿਹੜਾ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ ਹੈ that will be decided by the resistance of this circuit only, as no induced EMF is produced at that moment. ਜਦੋਂ constant current ਹੋ ਜਾਏਗਾ, steady current ਹੋ ਜਾਏਗਾ, self induction 0 ਹੋ ਜਾਏਗੀ, then electric current becomes equal to E over R. So electric current at any time during the growth is given by I is equal to I naught into 1 minus e raised to the power R over L into T ਦੇ ਬਰਾਬਰ ਆ ਜਾਏਗਾ. Now if time t is equal to L over R, then current I becomes equal to I naught into 1 minus e raised to the power minus 1 आ जाएगा, और I naught into 1 minus 1 over e, or is equal to I naught into 1 minus 2.718, or is equal to I naught into 1 minus 0.368, or this is to be equal to 0.632 of I naught, or 63.2% of I naught. So time constant of LR circuit may be defined as the time in which the electric current rises to 63.2% of its maximum value, almost 2/3 of its maximum value, or the saturation current or that of the constant current. ठीक है, so time constant of LR circuit may be defined as the time in which the current rises up to 63.2% of its maximum value, and time constant is ratio of L over R. If L is large, then the time constant is large, and the opposition to the growth of electric current is large, so current will take large time to become maximum if L over R ratio is large. So growth of the electric current will be slow. If L is small, means L over R ratio is small, then current will take lesser time to become maximum. So there is sharp rise of electric current in the LR circuit, and the variation of this electric current with time can be graphically represented taking current along y-axis and time along x-axis. Maximum saturation current is I naught, which is equal to E over R, and electric current rises exponentially with the passage of time. ठीक है, and this curve meets the horizontal line after time t is equal to infinity, and after one time constant, say when time t is equal to 1 into L over R, electric current becomes equal to 0.63 times of its maximum value. Theoretically, current will take infinite time to become maximum in the LR circuit, but practically almost in 5 time constants, electric current becomes equal to 99% of its maximum value. ठीक है, practically लगभग 5 time constants ਦੇ ਵਿੱਚ ਜਿਹੜਾ current है वो अप्रॉक्सीमेटली मैक्सिमम करंट के बराबर हो जाएगा, बट थ्योरेटिकली इट विल टेक इनफाइनाइट टाइम टू बिकम मैक्सिमम। ठीक है, only in case of DC source of EMF, current will take finite time to become maximum. If instead of this DC source, AC source is connected, then the behavior of this circuit is different than that of the DC circuit. ठीक है, उस केस ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਇਹਦਾ ਰਿਐਕਟੈਂਸ ਹੈ that is to be given by R square plus XL square and the current becomes maximum instantly, almost instantly current maximize हो जाएगा। Now in order to study the decay of electric current, we release the Morse key। ठीक है, ਜਦੋਂ ਆਪਾਂ ਇਹਨੂੰ ਰਿਲੀਜ਼ ਕਰਾਂਗੇ, now the point M and N, these will be shorted with each other and battery is disconnected. Now at the time of releasing this Morse key, electric current is already flowing through the LR circuit is maximum। ठीक है, ਜਦੋਂ ਅਸੀਂ ਬੈਟਰੀ ਨੂੰ ਡਿਸਕਨੈਕਟ ਕਰਾਂਗੇ ਉਸ ਟਾਈਮ ਤੇ ਕਰੰਟ ਆਲਰੇਡੀ ਮੈਕਸਿਮਮ ਹੋਏਗਾ। ਠੀਕ ਹੈ, ਐਂਡ ਐਟ that moment as soon as battery is disconnected, current will start decreasing, करंट फॉल करेगा, रिड्यूस होना शुरू करेगा, and due to decrease of current, magnetic flux linked with the coil will change, again induced EMF produced which acts as a back EMF and opposes the decay of the electric current. Now at any instant of time, again let us consider I is the current flowing through the LR circuit and is decaying at the rate of, decreasing at the rate of di by dt. Therefore in this case minus L into di by dt is to be equal to IR आ जाएगा, as EMF of this battery becomes equal to 0 और बैटरी क्योंकि ऑलरेडी ਅਸੀਂ ਇਹ ਰਿਮੂਵ ਕਰ ਚੁੱਕੇ ਹਾਂ। ठीक है, चार्जिंग के दौरान साडे कोल इक्वेशन सी E minus L into di by dt is equal to RT. During discharging process, this battery is removed and these two are shorted with each other. Therefore, in this case, L into di by dt plus I into R is equal to 0. Now, again solving this equation, we get I is equal to I naught into e raised to the power R over L into T. Now this relation gives us the electric current through the LR circuit after time t of removing the battery. ठीक है, after time t removing the battery. Now as t increases, in this case e raised to the power minus R over L decreases, so electric current decreases. In this case at time t is equal to 0, so just at the moment of removing the battery, at time t is equal to 0, I is equal to I naught e raised to the power 0 or is equal to I naught, so that current is maximum at time t is equal to 0, and after time t is equal to infinity, current I becomes equal to I naught into e raised to the power minus infinity or I naught over e raised to the power infinity, I naught over infinity is equal to 0. So current will take infinite time to becomes equal to 0. ठीक है, current will take infinite time to becomes equal to 0. Starting के इस केस ਦੇ ਵਿੱਚ current maximum होएगा and finally it will becomes equal to 0 after infinite time, and decay of the electric current in the LR circuit is again exponential, and the ratio L over R determines the rate of decay of the electric current. This ratio again termed as a time constant of the LR circuit. So if L over R ratio is small as compared to 1, then current will instantly fall to 0. It will take small time to becomes equal to 0. And if L over R ratio is large as compared to 1, then again current will take large time to becomes equal to 0. So L over R ratio determines the rate of decay of electric current. Now from this relation, again after time t is equal to 1 L over R, electric current is given by I naught into e raised to the power minus 1 आ जाएगा, put t is equal to L over R, R over L minus L over R, e the power minus 1. So I naught over e or I naught over 2.718 or is equal to 0.368 of I naught. So time constant may also be defined as the time in which the electric current decays to 36.8% of its initial maximum value. Thus, again in this case, current takes theoretically infinite time to becomes equal to 0, but practically current becomes equal to 0 almost in 5 time constants. Now again taking current along y-axis and time along x-axis. Initially in this case current is I naught, which is equal to E over R, and decreases exponentially with the passage of time. So again this curve will meet the time axis after t is equal to infinity. Now in this case after time t is equal to 1 L over R, electric current decays to 0.368% of its maximum value. So 36.8% of its maximum value. Thus time constant may also be defined as the time in which the current decreases to 36.8% of its initial value or maximum value. Thank you, beta. This is all about the growth and decay of electric current in the LR circuit.